Okay, so welcome to Profitable Commercial Property Improvements webinar, and this is hosted by Kansas Spray Foam Insulation. So I will tell you a little bit about who I am and why we decided to put this webinar together. So I am the business operations manager here at Kansas Spray Foam Insulation, and a little bit of history about myself is that I have gone to Highland Community College and at Washburn University, and I have directed my studies into business management. And as I've been developing in our business endeavors here, I have decided to do an outreach program that'll help educate consumers on energy efficiency that'll best serve them. And so this webinar is first of many that's going to be developed. And a little bit about the company is that we have been in the construction industry for almost 30 years. We have built some houses, we've done some roofs, we have spray foamed, and so we've been doing that for almost 12 years now. And this particular company has been around for 5. And so that's kind of our experience. So I will, and so why we did this webinar is because we wanted to improve the consumer understanding of commercial building efficiencies and how to better serve their customers or investors. We noticed a trend of the same problems in a lot of the commercial buildings we walked into, and it was mainly for they just didn't know about building science. So this is our way of providing that information. And so our agenda today is we're going to have Robert Nanny. He's from Spray Foam Advisor. He's going to be speaking about building science and insulation. We're going to have Kevin Brower with Kansas Spray Foam Insulation. He's going to be talking about commercial roofs. And then we're going to have Sarah Jane Scott with Scott Temperature, and she's going to be speaking on our commercial HVAC systems. So after each speaker, we're going to, or while that speaker is speaking, you can post any questions in the chat, and I will collect all of those questions and we'll read those questions off to the experts after each speaker. And the speaker will also be able to pull those questions during their presentation if they want. Also, we'll have some allotted time for that, so not to go over too long, but if we don't get to some questions that are posted, we'll make sure to follow that up in our follow-up email, which is coming up here. So in the follow-up email that you'll all be getting, you'll be getting any of the unanswered questions, and you'll be getting a recording of the webinar so you can share. And you'll get information on all of the presenters. And I will be sending out a survey to kind of just ask a few questions about what you would like to hear about next. So, okay, so on to our first presenter. So I would like to introduce Robert Nanny. He has a Bachelor's of Science in Mechanical Engineering and an MBA from the University of Texas. He has more than a decade of experience on the cutting edge of spray foam insulation. He has helped hundreds of owners and managers grow their business with a unique knowledge base and building code expertise. Mr. Nanny has created Spray Foam Advisor, which offers web-based training and education with videos, articles, blogs to help solve problems for spray foam professionals and the construction industry. And I know from our standpoint for our business, Robert Nanny has been a great asset for us. So welcome, Robert.
Thank you, Diana. I really appreciate it. I'm going to all right. And we need to share my slides. right. So Amanda, the share screen function is disabled, is what it looks like. Aha, there we go. And presentation mode. Okay, fantastic. Well, we're off and running. And as Diana said, my name is Robert Niney. Thank you for joining us today. I'm going to be talking about a concept that a lot of building owners are just not familiar with, and that is building science. And then I'm going to tie in spray foam insulation and give a little bit of insight into how spray foam insulation fits into the building science function and the operation of a commercial building. And in many cases, a lot of this applies to residential structures as well. So hold tight. As Diana mentioned, if you have any questions, feel free to put those into the chat box. And when we get to the end of the presentation, I will be ready to take some questions. So first and foremost, let's talk about what building science is. Building science is typically considered the study of building materials and building systems and how they work together. And what this means is every building is comprised of different components, of a bunch of different little pieces. And as they come together, they have different dynamics, right? We all conceptually know that a metal building with no additional components, that's just a shell sitting out in the middle of the Kansas flatland, is going to operate completely different than a high-rise building in New York that's 30 stories tall and has all glass windows. We know that they're going to operate completely different, and just conceptually that makes sense to us. But how are they going to operate different? Well, that's what the study of building science can help us determine and identify and figure out. If we know what the building materials are and what systems are installed into a structure, that can help us better understand how that building is going to operate. And really, the first level of building science comes down to the building envelope control layers. And every structure is intended to separate us, the occupants, from the exterior, from the outside, from the stuff on the outside. And the way we do this is with these control layers. And we don't typically call them control layers. Normally, the bulk liquid layer, what we call it, is the WRB, or the water resistant barrier, or the drain plane. And it's designed to keep bulk liquid away from the inside of the building, or to prevent it from falling on us, right? To prevent rain from falling on our heads. What about the pressure boundary? We don't typically call it that. We typically call it the air barrier. And it's intended to prevent wind from creating havoc and wreaking havoc with temperatures and changing the comfort level on the inside of structures. The thermal boundary we typically call insulation, or refer to it as R value or U value. And this is how we control temperature on the inside of structures, is with some form of thermal insulation. And then the vapor boundary we typically call a vapor retarder or a vapor barrier, but ultimately it's some form of vapor control system to help mitigate and control the amount of moisture on the inside of a structure, and help maintain comfort levels by maintaining relative humidities in optimum zones. And that's really what a building envelope is designed to do. That's what it's intended to do, is to maintain, to provide these four control layers, and then maintain a comfort level on the inside of buildings. So when one of these areas breaks down, it results in some form of flow. And flow is any type of movement on the inside of structures. And this always happens from high to low. So from high pressure to low pressure, or from high temperature to low temperature, all of these items, liquid, air, heat, and vapor, they all move from high to low. So when down where I'm located in Florida, if you leave your front door open in the middle of summer, the hot, humid air from the exterior is going to move from the high pressure location on the outside, higher temperature, higher humidity, to the low pressure situation on the inside of the building. So that's why we tell our kids don't leave the door open, right? When your refrigerator is a great example, don't leave the door in the refrigerator open because the high temperature outside air is rushing into the refrigerator, lowering the average temperature on the inside of that space and changing the thermal dynamics of that structure. So, what type of problems do we see when building envelopes fail? Building envelopes fail causes all types of issues, right? We get complaints about mold and mildew. We see rot and deterioration. There might be structural failures if it goes on too long. And ultimately, for you building owners out there, probably the biggest complaint is comfort. Comfort issues are probably the most dominant problem that you hear about in the industry, and you're not quite sure what to do about it. And oftentimes, that's because just the comfort complaint alone doesn't point you to what the actual problem might be. You might get a complaint about a hot spot or a cold spot, and the issue might actually be a problem with the building envelope. So let's talk about what happens if the air barrier breaks down. If you have some form of air leakage, the HVAC system might turn out to be overworked in the long term, right? If you have a structure that now has a hole somewhere in the perimeter of the system, that perimeter, that air barrier, that boundary is intended, it's designed to separate the interior from the exterior. But if you have some type of penetration or hole, or uh, the insulation fell down, or the air barrier moved away from the exterior of the structure, or there's a hole in it for some reason, you now have outside air that's coming into the building at a faster pace than it's supposed to or than it otherwise should. This can result in issues on the inside of the building. And this means that that outside air has easier access to the inside of the structure. And because it has easier access to the inside of the structure, the HVAC system is going to continuously work to try to condition the inside of that space. And by working so hard, you might lead to an overworked system. It might result in higher utility bills due to the overworked HVAC system. And then ultimately, one of the key damaging factors from air leakage is moisture, because air leakage is the number one way that moisture moves, that moisture travels in a structure. And if we have warm, moist air that moves into a structure and finds a cold surface, we get condensation. And this leads to moisture problems and moisture issues on the inside of structures. Condensation, of course, can damage building materials, whether we're talking about gypsum wallboard or we're talking about insulation materials. Look at these photos here. This is an example of a commercial building that had fiberglass on the tack to the underside of the metal building. And due to air leakage, because air was able to get in and get behind the fiberglass because it's not an air barrier, that warm, moist air was able to contact the cold metal surface, and you result in condensation on the underside of that metal behind the insulation material. So this is a breakdown of the air barrier assembly in this structure that allows warm, moist air to result in condensation, which then can result in deteriorating effects on the inside of the building. Anytime you have wet insulation, whether it's fiberglass blankets or cellulose or any product like that, that material is going to lose value. It's going to lose its thermal insulation value, and it's going to become significantly reduced. And that material is going to have to be removed and dried out and typically replaced in that process. Obviously, any type of water, condensation, wet environment can lead to possible corrosion and mold. And when we get to the mold area, of course, mold is a scare word in the construction industry. And that can ultimately lead to tenant and occupant complaints typically to the owner of the building, and the owner, it's you that are responsible to figure out a solution for these issues. And the best way to approach this is typically to find somebody that can look at the entire structure and see what's happening to help give some ideas and guidance on how to adjust the structure based on what's fundamentally happening in the system at that point, right? The mold issues can also lead to odors or rot, where you might see all different types of damage on the inside of a structure. And if it's not temperature related, if it's not air related, if it's not moisture related, the other issue that you're going to hear about is comfort complaints. When you have erratic temperatures on the inside of buildings, when you have hot spots or cold spots, these types of environments can be terrible and uncomfortable for employees, and they can be awful for storage of different materials and components on the inside of buildings. If you can't maintain temperatures, all in all, it just creates a terrible environment to operate and work from on the inside of buildings. So here's an image of something where you can see moisture creating rot and actually deteriorating a roof deck, because condensation was allowed to get to the wood on the underside of that roof system, just creating all different types of problems, right? Other nuisances that when a building envelope fails, other nuisances that can come about include all types of different pests that can be allowed on the inside of structures, damage to products in warehouses and buildings. Of course, any type of comfort or interior temperature fluctuations or drastic comfort issues can complicate production and manufacturing processes. And then all of this falls under the guidance of maintenance issues. Anytime you have regular issues with temperature, moisture, and air, you're going to have long-term maintenance issues with that structure, because the structure is not operating in an optimum manner. It's not operating to the best of its abilities given its optimum parameters. So what are the typical solutions? Well, one of the solutions that we often see in large commercial buildings is that owners try to use fans to move and circulate the air to try to reduce the local moisture levels in that environment. Now, the problem is that this is a short-term solution and it doesn't really address the causes of condensation. It's trying to put a band-aid on the problem. Typically, what this is going to do is it's going to move the air around. It's going to create an environment where that high moisture level is moved to another location. And as long as you can move that moisture level to the outside of the building, you might not have immediate condensation, but it doesn't really solve the problem. When you have high levels of moisture in the building, this typically means there's some type of building envelope failure. And when I say building envelope failure, this is not limited to a structure that had a great building envelope and then all of a sudden there was a problem and now it's damaged and there's an issue. A building could have been constructed with a building envelope in mind that worked 10, 20 years ago, and there may be no damage to it, but it just may not work optimally in the current environment given your current situation. So taking an audit of the building envelope, working with professionals like Kansas Spray Foam to do an audit of your building envelope and what that looks like, it really gives them the opportunity to provide some better solutions. And those solutions really should revolve around reinforcing the control layers. When we can reinforce the control layers of a building, what we ultimately do is we tighten up the building envelope, we reduce the air leakage, we can better control temperature on the inside of these structures, and that ultimately leads to control of comfort and better comfort on the inside of these buildings. When we have real problems like wet insulation or wet materials, that gives them the opportunity to go in and pull out the wet porous insulation or fiberglass batts and replace it with an insulation and air barrier system such as spray foam insulation. And that's kind of what they do. It's kind of their expertise, is to go into these buildings, identify issues, and provide a solution that helps you with your maintenance problems, that helps you with your long-term operation of the structure. And we see different types of applications that are available for situations like this. And it includes interior applications like in these metal buildings here. and even exterior applications where they can apply spray foam on the outside of buildings and fundamentally change the way these buildings work by putting an insulation, an air barrier, a vapor retarder, and a drain plane all in a single application. And so that's what closed cell spray foam can do in these types of environments. In this situation, as an interior insulation product, it's going to offer the insulation and the air barrier on a single continuous plane. So you get the benefits of continuous insulation and you get the air barrier operating on the same plane as the insulation, which has many, many benefits for the structure. When it's installed in an exterior application, it actually becomes a 4-in-1 barrier where you have an insulation, an air barrier, a vapor retarder, and a drain plane all in one application. And this works in residential structures and it works in commercial buildings. So you just have to figure out the best way to integrate these types of products into your designs. And that's something that a company like Kansas Spray Foam Insulation can help you do. So let's talk about a sample investigation, an example situation where a building envelope failure of some kind occurred. We'll say mold is spotted visually, and that triggers a complaint by the building owner. So during the investigation, I go in and I find that there's condensation inside the structure, and nearby there's a building envelope failure, specifically an unsealed portion of the perimeter of the building, allowing a direct path for air leakage to come inside the building. So on a specific project that I was on, there was a 200 square foot area that was missed by the previous insulation contractor. And that 200 square foot area led directly to an overhang out over a wet area, a pool and sauna environment. And so that pool and sauna environment, creating moisture, creating a high humidity situation, it had direct access to the underside of this space that directly went into the essentially the attic of this building. And as soon as I popped my head into this structure, I could feel the temperature and humidity differences in this space. I could actually feel the accumulation of moisture in this space. And when the warm, moist air in that space comes into contact with the building, when it finds cold surfaces, it results in condensation, and that can lead to mold and mildew. All you need at that point is some type of organic food matter for mold and mildew to start growing. So we need to figure out the best way to address this situation. And for example, in the specific project that I was on, the best way to address it was to attack it at the source. And that was by cutting off the access of that warm, moist air from the outside, providing the insulation and air barrier in that 200 square foot area that was missed, and ultimately sealing up the leakage point by tightening the envelope and air sealing that location. And that's really the type of work that can be done when an audit is done on your building envelopes. Ultimately, some of the key takeaways from this overarching concept is to look for opportunities to reinforce the control layers of your buildings. You want to look at items like mold and mildew and pests, and these things can be significantly reduced. The risk of having these type of issues on the inside of your structures can be significantly reduced by reinforcing your control layers. When you do this, it leads to other benefits as well. When you reinforce the control layers for these other ideas that we've talked about, to reduce condensation, to reduce air leakage, to maintain better comfort control, you also get a secondary benefit, sometimes that might be a primary benefit, energy savings. And that energy savings leads to a return on investment that might be very, very beneficial for your organization. Ultimately, all of these activities and all of these concepts are maintenance activities that are tax deductible. So you get another benefit in this process. It's not just a cost to the business, but it also becomes a tax deductible resource for the business. And ultimately, if you're dealing with tenants, when tenants are comfortable, they stay longer. So you get another benefit by optimizing the way your buildings operate. You get all of these benefits long term, ultimately resulting in the ability for you to operate your structure in an optimum manner, right? Ultimately, upkeep and maintenance is your chance to fix things and get them done right. Ultimately, the building envelope is your priority when it comes to comfort and the way your buildings operate. And one way to do it is by working with an organization like Kansas Spray Foam Insulation to take a look at your building envelope, see how it's operating, and let them give you some tips and tricks on the next best steps to help change the way your structure works. My name is Robert Niney, and if you have any questions, feel free to shoot me an email at robert@sprayfoamadvisor.com. I'm happy to help at any point in time. If you have any questions about having a review of your building or having an audit done on your building envelope or the control layers for your structure, touch base with Diana Brower and Kevin Brower, the team at Kansas Spray Foam Insulation. They will be able to take care of you and help you out. Thank you very much. Diana, I'm going to turn it back to you.
All right, thank you very much, Robert. There were a few questions that I'll pose to you here real quick. So the first question is, can my building be too tight? Doesn't my building need to breathe? I know we've heard this before, so can you answer that?
Sure. Yeah, it's a great question. And I talked a lot about air leakage and air tightness of a building. And ultimately, when we tighten up envelopes, we change the way the building works. But this question, doesn't my building need to breathe, is something that I have heard often, that I've heard for really as long as I've been in the spray foam insulation industry. And I will say that statement is a little bit of a misnomer, and it sometimes gives people the wrong idea, because when we talk about breathing, we as people tend to think of breathing in terms of air. And really, buildings don't need to breathe air, right? They don't have lungs. It's not air that they need to breathe. What buildings need to breathe is vapor. Buildings need the ability to either trap vapor on one side of the assembly, which is why in certain climates we put vapor barriers in our wall assemblies to prevent vapor from going into the wall itself. So in a northern climate like New York, we're going to put a vapor barrier in the wall assembly to prevent the interior vapor created by eating, breathing, bathing, cooking, sleeping, etc. We're going to prevent that vapor from going into the wall assembly, because that cold exterior wall assembly can then result in condensation. In other climates, we're not going to put any type of barrier in the assembly. Like where I'm at in Florida, we don't put any type of barrier in the assembly, because we want that wall system. We want the building to be able to breathe from a vapor standpoint. And so the concept of a building being able to breathe is really more about vapor control, and it's not about air leakage. The ideal building, if we looked at a perfect structure that operates better than pretty much any other structure that we are familiar with, I kind of alluded to this earlier in the discussion, it's a refrigerator. A refrigerator is the optimum building envelope. It has a perfectly airtight enclosure, a perfectly watertight enclosure. You have very little communication from the inside to the outside, from the outside to the inside, and you have an air management system that conditions the inside of that space. When you open it, you change the dynamics of that structure. So the ideal way for that structure to operate is to keep it as tight as possible, and then take care of the indoor air quality from the inside out using a proper air management system. And I think that's something that Sarah Jane is going to talk about in her discussion. But ultimately, can a house be too tight? Can a building be too tight? No. We want to tighten it up as much as possible from an air leakage standpoint. We'd rather have no air leakage at all if we can possibly help it. Now, we never get to perfect. There's always going to be some amount of air leakage. And then we take care of the air from the inside out. And oftentimes that means some amount of ventilation and bringing in fresh air from the outside once we've created that building optimally, once we've tightened the building envelope.
All right, great, thank you. And there's one more question. Does spray foam absorb moisture?
Yeah, that's a good question. It's something, especially in wet environments, to be aware of. And the best way to explain this is that even open cell foam, so closed cell foam, two different types of products that you might come across if you're not familiar with spray foam insulation. Open cell foam is similar to the soft, squishy foam that is in maybe a couch or a bed or your car. Closed cell foam is going to be higher density, it's going to be more rigid, and it's going to be harder to the touch. Closed cell foam has very, very low water absorption, and it actually has a very, very low perm rating as well. So we don't get much moisture movement through closed cell foam, and we definitely don't get moisture, like moisture absorption in these products. So neither open cell nor closed cell foam is going to act like a sponge and wick moisture out of the air. So that's not how they work. For them to get wet or for water to go into them, they have to come in contact with bulk liquid, with actual condensation or water. And it's not just going to be moisture in the air that results in wetting of that material. Open cell foam, water, bulk liquid can go into it. That's one of the reasons that it's going to be limited to interior applications only, interior use only. And with closed cell foam, you have a little bit more forgiveness. You can actually use it below grade. You can actually install it on the exterior of buildings. It can come in contact with water. It acts as a secondary water resistant barrier in many cases. A lot of other benefits. So your open cell foam is going to be limited to insulation and air barrier applications. Your closed cell foam is going to have a lot more versatility and can be used in other applications. It can come in contact with bulk water with no problems.
All right. Thank you very much, Robert. I think
Thank
that answers
you.
the question pretty well. All right. So we're going to move on to Kevin Brower. And just to give you a little bit of history about Kevin is that I'm going to share my screen here real quick. If I can, yep, here we go. Here we go. All right. I think Kevin's up there now. All right. So Kevin studied computer engineering at Kansas University. He has more than 30 years experience in roofing, specialty coatings, insulation, and general construction. He has successfully owned and operated roofing companies, a property management company, insulation, and coating companies. With Kevin's engineering and construction principle knowledge, he has a unique knowledge to competently evaluate projects to make recommendations for customers for proper remediation. And so with that, I'm going to have Kevin come on and do his presentation. Hey, Kevin.
I'm going to go over the commercial roofs and how they fit into the building efficiency. Okay, so I just clicked that to change it, right?
Yes.
Okay. We're going to start out with built-up roofs. We'll touch on the single plies, and we'll go into spray polyurethane foam roofs. And begin with the built-up roof. In case you don't know, it's kind of a dinosaur. They've been around a long, long time. A lot of them are tar and gravel. Some of them are mod bit and such. But one of the inefficient things about them is that they just retain a lot of the sun's heat, and which would be nice if you could turn that on in the wintertime and shut it off in the summer. But it tends to make the HVAC systems work extra hard throughout the summer months. They typically have a lower R value. It wasn't until the last probably 10, 15 years that they really started putting actual insulation underneath them. And again, that's, it was typically a high density board, that particle board. It was not an actual like foam board or, true insulating material. Another inefficient thing about them is that their maintenance is kind of expensive, and they require regular maintenance. You have to go back. It is possible to like resurface them. Kind of expensive to do because there's typically a lot of ballast rock on there. that needs to be moved out of the way. Then the roof's recoated, then the rock's put back. If you actually go into a replacement, you're talking pretty excessive expense there just on landfill cost. You got to have a place to take the rock to. You have to have a place to get rid of all the old roofing material, and it's really heavy, it's bulky, it's just not the most efficient thing. It was a good roof for what it was designed for when they started using them. Now trying to make a building more efficient, they're really just not it. There are possible improvements to a built-up roof. I mean, if it's not too far deteriorated. If you see the picture on the lower left, those are actual blisters in the roofing membrane underneath the gravel, and that's not a good sign. That's usually means there's a bigger problem underlying that. If you don't have real big problems like that, you can remove the gravel and actually do a coating or a foam and coating over it and get yourself to a sustainable system, and make it airtight. Now that's pretty much where you're at. You could add foam on top of it, foam board, go over it with a coating. But the most efficient thing would probably be doing the spray foam and coat. Now, the next material or type of roof is the single plies. And they're really kind of cool. I mean, I've worked on a lot of these, installed I don't know how many thousands of square feet of them. They're pretty fascinating. They're much less expensive to install. But the first one I got here is an EPDM, which excuse my typo. But the drawback to those, when they first came out, there was black and white. You could get two colors, but now they've just probably, I'm going to say 15 years ago, they stopped making the white available at all. And the problem is, as you can see in this top picture, it's black. It soaks up the sun. It gets mighty hot. Again, you can't just flip the switch and change the color of it, to help with your cooling in the summertime, and then flip it back to black in the winter to help with the heating. And the other problem, I mean, this picture looks really nice and it goes down nicely, is there's joints in that roofing. And so that means that there's places for possible failure. Also, you can see in this picture that they put down a board, and this looks like a high density board, not even an actual foam board, insulation board under this. And again, offers a little bit of insulation, but not enough to counteract the black with sun on it in the summertime. All those boards have to be cut to fit. They're only going to be so tight. Whereas if you had something that was formed in the place, it's going to fit real tight, eliminate the air transfer or the ability for air transfer, and also extend your actual R value, so to speak, right up to that object. Whereas a hand cut piece, there's some mighty skilled people out there that do a very nice job, but there's still the ability for that to move and not be up against it. So, they go on easy. That means they're less expensive to maintain, and, they're less expensive to replace. But the membrane does wear out. I mean, you're a 45 mil material, you probably get it to last, 10 to 15 years. I think that's where the manufacturer's warranties run. And then you can go to a heavier mill product, which is a thicker material, and it'll last, you probably get a good 20 out of it. Problem is, it starts shrinking over time because of the manufacturing process, and it'll pull itself apart at the seams, allowing moisture in. Well, once moisture gets into that insulation board, as Robert Nanny said, it starts breaking down, it loses its effectiveness, and then your efficiency is gone. Now, the next single ply we have is a TPO, and there's PVCs also. I've slapped those together because they're very closely related. They're typically white. awesome part about that is it reflects that sun's heat. As you can see in the picture, though, there's a lot of joints when you got to go around objects, because you're taking a sheet of material and you're trying to make it fit a given shape. This opens the door for failures. And also, it has the same type of issues as the EPDM does with the insulation board. They don't always use a fiber board under there. And a lot of times they'll use a foam board, but they don't anchor it in place. What holds it in place is the fastening of the membrane itself. And so your sheets are, a lot of times, if you got a 7-foot wide sheet and it's 50 feet long, it is totally possible to have a 4x8 sheet of material just float around underneath there. I've actually been on roofs where those sheets have blown off, and due to the wind and the vibration, they have gone and they're like doubled up in one spot and nothing in another. I've actually seen that on, I believe it was a Kmart was the last one I seen. But and if that happens, then you've completely lost your insulation value where that sheet used to be. Let alone the joints. Obviously, if it's free to move like that, there's nothing addressing the joints between the sheets. Now, I have seen jobs where those are taped, and those are better, mainly because they help stop that movement around, and they also help eliminate the airflow through. But you still don't have a perfect fit junction. You don't have continuous insulation. And again, that product also suffers from the possibility of shrinkage and what have you. Both of these products can be actually, I know the EPDM can for certain. It just depends on what stage in degradation it is. And I believe the same goes for the TBO. They can be coated with a very reflective material to help solve the energy issues that you'll see. And also, when you go back with a coating, you got a monolithic membrane there. So it's basically custom made to fit your roof. Now, the next slide is actually a spray foam roof. As this picture, you can see the guy there spraying it on. Basically, if everything's sprayed in place, it's fitting everything. It's monolithic. There are no joints. It's just solid, custom made. Theoretically, if you could pick up that piece of foam off that building, it would look like a mold of your building. That's how tightly that fits. And from an energy efficiency standpoint, that's probably, I don't know of a better way of doing it in all my years of being out in the industry. Now, there are different types of coatings that you can get on to put on. They usually have a base coat and a top coat, which typically is the same type of product. It's just different colors, and they use that different coloring, as you can see in that lower left picture. What that does is, well, with the acrylic especially, because the acrylic actually wears away. So when you start seeing the color of the base coat, you know it's time to put a new top coat on, and that'll happen before there's any damage to your foam or anything below. So essentially, the need for repairs is being minimized, with the exception of, I don't know, somebody dropping a brick or something, a sharp object on the roof. You can walk on them all day long and it won't hurt them. So you're eliminating those needs for repairs, and you're being proactive without even realizing it, because you can see, well, hey, I'm starting to see my base coat here. It's much less expensive than anything else to just put a new top coat on. We have a job in Lawrence, Kansas. We're going to be doing that too here in the next few weeks, provided the weather warms up. That is the biggest stickler. Well, and that's with all commercial roofing. You really need to be like 40 and rising across the board. There's also, I mentioned the acrylic coating. We can also do a silicone coating, not just us, but anybody that installs these. And if you really want an industrial take a beating roof, you can use a polyurea product, which is similar to a bed liner for trucks. You can throw the brick on there. You're probably not going to hurt it. So they're much more sustainable. There is next to no reason to ever tear off a spray foam roof unless it's just been completely neglected beyond its serviceable time, just because of your ability to recoat. Now, do all these coatings interchange with each other? No. If you have a silicone roof, you can't go and put an acrylic or a polyurea on top of that. But you can, if you have an acrylic, you can put the silicone or the polyurea over that down the road. They literally just need, you're down to a coating process. Again, much less expensive. And if you ever did really have to remove one of those roofs, the worst case scenario is you run a scarifier over it. It removes the surface of the foam, and that allows you to refoam, add a little more foam, and then a coating. So you're still not dealing with the expense of complete removal. And your landfill fees, your labor times, all greatly reduced. Now, just to kind of sum up what I went over, built up roofs, they're a solid roof. They're kind of like the Sherman tank of roofs, but they have their flaws. They wear out. They're expensive to maintain. My experience with those is that in reality, they should be inspected every 1 to 2 years just to look for areas that might be failing. Doesn't mean the whole roof's bad, but it can be addressed. But it's kind of expensive, and they're making more cold applied coatings for them. Even the acrylic you can put on them, and they're getting better, but they don't offer much in the way of insulation. This picture shows you here. The built up is usually a dark roof, and you can see in this illustration how your brighter roof will reflect more of the sun's heat, which is really what beats up your HVAC system, which I'm sure Sarah Jane can explain to you better than I. And I know that asphalt has an E rating, which is the little letter they use to designate how much sun radiation or heat a product soaks up, and asphalt is the highest product known to man as far as its ability to soak up heat. So like I say, if you could turn it on in the wintertime and off in the summer, you'd probably have your $1 billion patent. The single plies, they're not as long a term product. They have their issues with how the insulation board, or whether the insulation board has been used. I've seen a lot of them where they just stretch them over the existing roof, whatever happens to be there. It's a good quick way to get a temporary seal. Not necessarily going to take care of you, probably do nothing for your energy losses. You got to have that solid layer of insulation in there that fits the object it's on, be it around an HVAC curb or a plumbing vent stack, or geodesic dome. I mean, we've seen them on those, and trying to piece together something with pieces and seams to fit stuff like that, and to stand the test of time is a very difficult task. That's where your SPF, or if your spray foam polyurethane, is really the icing on the cake as far as all that goes, because it molds to that shape. It fits the job. So that's the bulk of what I have. If you'd like to ask some questions, feel free.
All right, I think we have a few questions for you, Kevin.
And you have to unshare.
As soon as you unshare.
Unshare.
All right, there we go. All right, I do have a few questions that came in. One is, what if you have a ballast roof?
Well, a ballast roof, first, you got to know what that is. It's where they've put gravel or walking pavers to hold down and it's typically a membrane. A gravel ballast is used on a lot of tar and gravel roofs because it's trying to protect the tar from drying up in the sun. But literally, it creates more work. You got to remove the ballast, get it out of the way, do what you're going to do, and depending on what you want to go back with, if you're going back with if it's a built-up roof and you want to re-flood coat it, and then you end up putting the gravel back on it as that protection layer. Their ballast roofs are they were an inexpensive way of holding a roof on when it comes to the single ply, because they could come up and they'd spread gravel, there's river rock all over your membrane. The drawback is it's hard to find the leak. I mean, just picture, if you will, somebody's taking a $100 bill and sticking it under the gravel somewhere and saying, "Hey, there's $100 out there if you can find it." You're gonna have a lot of time. It's a tough thing to work with. We run into quite a few where we just end up removing it, going back with if it's a case. The last one we did was about 35,000 square foot EPDM roof that had ballast on it, so nothing was anchored underneath. And we ended up actually putting a recovery board over the top of that existing roof after the removal of all the river rock and spraying an inch of foam on there to get the monolithic seal on everything. And then we coated it. And the guy sold off the river rock that owned it. So the ballasted roofs, they're interesting. They're kind of neat and all, but they're not the answer when it comes to maintenance down the road. They're a lot more labor intensive.
Okay. All right.
I
Well,
think
thank
on
you.
that job. What's that?
No, go ahead.
I was going to say, I think on that job I referenced there, it took the guys 5 days to get all the rock off of it, just so we could go in and fix. And after they had done so, I would imagine there's probably over 500 feet of seams that had been repaired. Somebody had to go through, move rock, find that seam that was failing, put it all back together, and then cover it back up. It's just more difficult to manage.
Right. Right. Thank you. One more question is that came in. This is a good one. Does roof foam stop roof leaks?
Roof foam will stop a roof leak. The idea of the coating, one, is to get the reflectivity. The other is to protect the foam from the sun's UV, which would breaks it down over time. We can also add things like aggregate to the coating. It helps deter birds from working on it, because some places have bad problems with that. But the roof foam itself will stop the leak. 10 years ago, maybe 12 years ago, I was on a foam roof in Phoenix, Arizona, had no coating on it at all. And at that time, the roof was 30 years old. It doesn't rain all the time in Phoenix, but when it does, they call it monsoon season for a reason.
Okay. All right. Well, thank you very much, Kevin. Now we're going to move on to Sarah Jane. All right. So just a moment here. Sarah Jane is the third generation owner operator of Scott Temperature. Sarah Jane holds a master mechanical and a mechanical contractor's license. She is also a certified ResNet energy auditor. Woohoo. Sarah Jane strives to deliver customer design solutions for her clients, including high efficiency VRF and ductless mini splits, ground source heat pumps, air source heat pumps, and other energy saving products. So let's welcome Sarah Jane. And I am going to stop sharing. There you go, Sarah.
Thank you, Diana, and thanks for inviting me today. And
Yes.
Robert and Kevin, being able to listen to another piece of the building envelope and the thermal values of the buildings and pieces that I look at every day was helpful. For commercial HVAC, the big thing for the building owners and for the tenants is the efficiency. And then for the tenants is the comfort in the space. If the tenants are comfortable in the space, they're more likely to stay in the space. And so you can retain your tenants by keeping them comfortable. HVAC commercial, energy use and equipment is a great example of the good, the bad, and the ugly. So when we go and look at systems, we see plenty of systems that we put a new rooftop on there in the last 2, 5, 10 years. Those are good systems. They're good, mechanically sound systems. Then comes the bad, the rooftops that you can tell yourself the outside casing of the rooftop is rusted, there may be cracked, there's from where the flue and the gas combustion process is, there may be burn marks, soot marks on the outside of the units. So that's where you look at the bad. It may have literally Band-Aids. You can see a new fan motor strapped in. And then you have the ugly. You have the 30-year-old equipment, the boiler in the pit in the basement that's not only difficult to work on, but it's dangerous for the building and the safety of the occupants. So you can determine by the look and the age of your equipment where you stand on this. On the interior of the building, you can also tell when you go in, when it's occupied and you see the occupants. When I walk into an office building and I see a space heater in every cubicle, it's like somebody scratching their fingers on a chalkboard for me. I just know that their energy use is way too high. I'm sure that everybody complains all the time about the space. It's really difficult to look at. So we'll talk about how you can mitigate that and the different ways to solve it. Now, talking about occupancy and building use, especially over the last year, the HVAC and your ventilation strategies are very important for indoor health based on your occupancy and your public use. So by code, there's ways to ventilate because we've air sealed the building. There's ways to ventilate it where we are still conditioning the air that we're keeping in the building and we're cleaning it for the occupant use. And then everything comes back to comfort. How are your tenants and how are their employees comfortable in the space? So when you have ugly equipment, it's beyond its useful equipment life. We've had upgrades in the refrigerant. So the gas that's in the system, again, it's under pressure and it's a gas. So when it leaks and it's gone. To replace it on the outdated is expensive. So that adds one level of repair costs when you have really old equipment. The last refrigerant upgrade was the old was phased out of production about 10 years ago. So we can have units that don't look bad, but still have the older refrigerant, which makes it costly to repair. The efficiency of old equipment, you can't put a better blower motor in. You can't make a better economizer to bring your outside air in. The pieces are just not available for the aftermarket upgrades. And then of course, back to the comfort. You don't have comfort in that space. You have hot spaces, you have cold spaces. Even if you improve your building envelope, you're not going to, from a 20 or 30-year-old design, you're not going to have the right design for the change in use, the change in occupancy, or the upgrades that you've done with the rest of the building. So we're really looking at replacement then. When we look at replacements, so the smaller the space, the more you can use a split system that you're traditionally used to looking at, like the furnace and the air conditioner, furnace and the heat pump in your own home. Those capacities go up to about 120,000 BTUs in heat and 60,000 BTUs in cooling. So office area, 5 or 10 employees, 1,500 square feet, you could go with a split system like that with ductwork. That's probably the least expensive way to take care of that tenant space. Now, when you have multiple tenants in the spaces, you generally see the rooftop units. So the big boxes on the roof. It's a sealed system. So it comes from the factory with that refrigerant in it and sealed. Anytime you get a sealed system from the factory versus a field fabricated, you're going to have less room, less likely to have leaks due to air field fabrication, length of line set, length of number of fittings. So those packaged units, the rooftops, are a very good option for multiple tenants, especially when you can put them on the roof. When you go past they have a base efficiency for most units. So you're looking at your efficiency and you're not really able to go much above a 14, 15, maybe a 16 SEER air conditioner. They start at an 80% and go into the 90, 92 range for the furnaces. So you're not worse than conventional systems, but you're not better. To get to the better side, most of the time we're going to the high efficiency, all electric heat pump options. So you have an air source heat pump, which is just like your air conditioner, just like your rooftop package unit. It is a sealed system and it comes that way on the refrigerant side. And the efficiencies go from 18 SEER up to about 30. So you've come a long way from a basic 13 SEER conventional or rooftop when you're pushing 30 SEER on a ground source heat pump. So an air source heat pump uses a condenser coil outside. A ground source heat pump uses a series of loops and tubing in the ground. The advantage there, the air source works at 5 degrees, 0 degrees, negative 11 degrees on Saturday, outside air, and cannot take much heat to move it into the space through the refrigeration circuit. The ground source unit, that loop is at 55 degrees in our area here in Kansas, and it is constantly extracting and rejecting heat to that constant temperature. So there is no diminishing returns on the amount of heat it can extract or reject. Now, when you go up in efficiency from that, that's when we're talking about the high efficiency, all electric, variable refrigerant flow systems. So that's the VRF. So on the small side, on the residential side, on the server room, which we'll talk about how to treat those technology rooms that are popping up everywhere, that weren't there on your 30-year-old system. The variable refrigerant flow allows you to change the unit, uses only the capacity it needs at any given time. So if you need to move, because the outside temperature is 60 and you want your inside to be 68, and you have an 8-degree temperature difference, you have a real low capacity. If you're at 30 degrees, you've got a whole lot more BTUs, heat that you need for that space. And if you're at 0 degrees, you need the entire unit at full blast. So the variable refrigerant flows measure the refrigerant flow based on the needs of the space. So that makes them the most efficient because you get the highest efficiency in every capacity. So you'll see those ratings up to 30 SEER, 25 EER, like you do the ground source units. The best, when we're talking about good, bad, and ugly, when we're talking about the best, when you have mixed use spaces, restaurants, shopping malls, and your tenants have air conditioning needs in the middle of the winter, kitchens, server rooms, VRF has a heat recovery system, which it actually will take the heat that it extracts from one space and it will put it in the other space by means of that refrigerant flow. So the refrigerant gets hot as the warm air comes over the coil. That same pipeline goes through and comes over to the coil that needs heat. and makes that coil hot. So the air going over it becomes warm. So it actually moves the heat through the refrigeration lines from space to space. So another advantage of the VRF is that you can pick up the heat recovery side. So if you have those different uses spaces, you can have equipment to basically, it's not even the compressor moving because it's just the refrigerant moving. So it's just the pump action of it. So it's very efficient to take that heat and move it instead of extracting or producing that heat from a different source. So if you want a really great system to replace that 30-year-old system, we have it. Is it expensive? Yes. Yes, it's expensive. Is it easy to maintain? It's super easy to maintain. Generally in the VRFs, every individual space has its own fan coil. It can be a big space. It can be an 8-ton fan coil, or it can be small. It can be 9,000 BTUs, 3/4 of a ton fan coil. The one there, that Samsung is part of a ductless system, a mini split for a home, for a server room. It's about a 9,000 BTU system, but a head unit, an indoor coil unit, much like that, can be used on the large VRF systems to take care of the smaller spaces. So instead of cubicles having heaters under them, you can have small units like this, so you have individual temperature control. So on the VRF side, you're all in heating and you're all in cooling. On the VRF side, you can be simultaneously in multi modes. So you can have one tenant be heating out of their small unit, another one be cooling at the same time. The VRF heat recovery will actually take that heat extracted to cool the space and heat another space with it. And then the ductless mini splits, the smaller units, the babies of the VRF world, the ductless mini splits, they're single use. So everyone's in heat or everyone's in cooling. So that's also another option of where, if your space always is heat or always cool, you can go with the smaller, less expensive ductless mini splits, which have different indoor coil models. They're not all the high wall. We have ducted units. We have ceiling cassettes. We have ones that look like old baseboard radiator piping. So you have a variety to cover all the spaces. The VRF is very flexible that way. We may duct one of the units to a space, but we don't have the big bulky duct work that we have to run from space to space. So when you have a rooftop, you have these big ducts that come through the ceilings and they go everywhere. They waste a lot of room. On the VRF, we have refrigerant lines. So insulated copper pipes that run from the outside unit, they T and Y and manifold off to the indoor units. So you save a lot of space that way. And it's a more efficient way of moving that heat than through the air, is moving it through the refrigerant lines. So as we've gone from conventional and rooftop all the way to VRF and the VRF heat recovery, we have increased your energy efficiency, so decreased your utility costs. I'm not seeing in the chat if any questions are coming up. So if you have any questions, I'm used to being stopped a lot and ask questions as I talk. So if anything comes up, that's just fine too. Part of the comfort is being able to maintain each space at that temperature. And now with the public use and isolation of different occupants is being able to provide fresh air. So when we talked about the really old system, we said that the fresh air, they probably didn't have fresh air. Maybe the building wasn't real tight. And now that we've tightened it up, the air gets stale inside. So there's a few ways to do it. Energy efficiency wise, there's advantages with each one too. So we can just bring in outside air, drop it into the return, and then condition it with the air that we condition in the space. So that's a 8-inch hole to the outside, and air is pulled in by the furnace or rooftop fan. It's got a damper on it, so you can manually change it. In the moderate months, you can open it up at night. You can open it up to provide a little bit of cooling into the building because of the outside ambient lower temperature. The rooftops now all require manual or economizers. The jurisdictions with the higher codes, the better, newer codes require the economizers. What that makes is the outside air a automatic system. So it knows the outside temperature, it knows how long the equipment's been running in the space, and it brings air in based on that. And then you can say, I only want the minimum amount or I want the maximum amount. A lot of places right now are running with that maximum amount. Is that changing the energy use in the space? Absolutely. You're conditioning a lot more outside air at a 0 to 100 degrees than you were a year ago. So is it increasing your energy usage? Yes. Is it better than opening a window or a door on your energy usage because you're able to control it and temper or condition that air before it gets to the occupants? So it's much better than opening a window. The best way to do it is they have a box that is an ERV or an HRV. So it's an energy recovery or heat recovery system. So you bring in outside air, it crosses a heat transfer plate that partially conditions the cold air to the warm conditioned air, transfers that heat, or the opposite way, the cold transfers back to the incoming hot air, so that you temper that. And again, it's based on a fan, so you're paying for the fan, not for fully conditioning the true full outside air. So that's the most energy efficient. And after the cost of the equipment, because you're just paying for the fan usage electrically is much less than conditioning the raw outside air. So those are the different efficiencies. If you have ugly equipment, if you just have bad equipment, then you may be able to buy aftermarket manual or economizer outdoor air dampers to help the health of the air inside. You can increase the fans, motors, the blower fan motor to ECM, the better fan motors that run on less electricity per day. So there's some aftermarket upgrades for the bad, but you still have your refrigerant that's expensive to work on that closed sealed refrigerant system, because when you have a leak, it's a gas and it's gone and it's expensive to replace because it's the phased out models. So you can do a little bit of efficiency upgrades on the bad, but you really should be looking at budgeting options in for replacement. Now on the good, on the system that you've put in the last 2 to 10 years, and it's sitting empty or it's being used a lot more than it was a year ago. There are aftermarket upgrades you can do. There are economizer kits that are made for that unit because they're still in production units. You can add an ERV in and temper that air before it hits the airstream of the rooftop or the conventional system of the VRF system. Most VRF systems, we don't want to bring that raw outside air in, so we're bringing it through an ERV for parts of the building, specific tenants in the building, or we can do it as a whole building approach. The other way to improve your energy efficiency, whether you have good, bad, ugly, or a fantastic VRF system, is maintenance. So all property managers, owners or tenants who are responsible for the repairs should have a good maintenance program in place. Most studies that cover energy efficiency say that if you have a maintenance plan in place and you are regularly changing your filters, cleaning the coils, and checking the mechanical operation of the system, that you're saving up to 15% on a commercial system in energy costs. When you have dirty coils, you are creating a low heat transfer instead of a good heat transfer. When you have dirty filters, you are creating an extra workload on the blower motors to move the air. And then when you have low air movement, you have low comfort control, humidity and temperature wise in the space. So that maintenance is extremely important to do. It also prevents costlier repairs. Someone is looking at that system monthly, every 2 months, every 6 months, each season, to see how the equipment is operating. The rooftop units that use belts, that belt slipping, it's hard on the motor, it's probably loud in the space and somebody's complaining. And then when it breaks, you have nothing. So somebody up there changing the filters, looking at the belts, checking operation. The operation performance is not just the mechanical, but also the efficiency performance of the system will save you the money and energy costs over time. And then we said that we would come back to server rooms. So server rooms are not just a closet anymore that has maybe a CPU in it. They have the computers produce heat, and generally because of the hum, the room is closed off from the other rooms. This is a completely different environment than any other space in the building. And so at first they just used a split fan coil and an air conditioner that could work at low ambient outdoor temperatures. Your efficiency is 8-10 SEER at the beginning of that. Now, if you do that, you're at a minimum of 13. You may be getting a 15 SEER rating. As you go to a dedicated system, like a mini split, or if you incorporate it within your VRF, you're moving those efficiencies up above 20, maybe even up to 30 SEER. Maybe you're removing that heat from your server room and putting it into your office space, and you've only got the fan power as the heat transfer, as the heat moves through the refrigerant lines. So you're really transferring the heat free. So that's the best energy efficiency. Those server rooms do need to be addressed though. The air conditioner in that room will produce condensation and it needs to be removed. You don't want it in the other spaces. So treating it separately is the best option. And then because you're using it in cooling all year long, your higher efficiency equipment is going to save your money. But then again, you need to maintain it and clean your filters, clean your coils, and make sure it's operating correctly. So as you have tenant turnover, different tenant use, or different occupancy loads, a lot of jurisdictions will require the new tenants coming in to have an engineering report, even if it's the same use, especially in restaurants. Even if it's same estimated use, they'll have you do an engineered copy of your HVAC or mechanical electrical plumbing drawings. It's a large expense for a new tenant coming in, but in the long run, it is, there are a lot of helpful features of the report if it's written looking forward. So not just modeling the existing equipment and ductwork that's in the space and showing that, yes, they're going to have 10 people and they're going to have this kitchen equipment and it'll work just fine. But how about at the same time, because it's the same report, that they modify the duct system to change with the occupancy of the space. They define the actual heat load, the heat gain and heat loss of the space based on the right now building materials, the upgraded spray foam roof deck, walls, the upgraded windows, so that they drill down that capacity. So when you're ready to replace or when you have a large repair, you can look at equipment that's made better for the space. Again, increasing tenant retention and occupancy comfort. So most people kind of get scared when they say they have to have that engineering report, but there are some benefits to it. And if you use it as a tool to project a budget in the future for your HVAC needs in a space, it will pay itself back in occupancy cost, tenant retention, and energy savings. So if you have any questions, I have plenty of time to answer them. I don't see anything popping up. Do you have anything, Diana?
There was one, I think you may have answered it though, but I'll restate it. And if you want to expand, that would be great.
Sure.
One of them was, let me see, if the roofing system changed to a more efficient roof, how would the current HVAC system be evaluated for optimum performance to save energy costs and equipment? So like if somebody were to do a really energy efficient upgrade, calling you in to take a look at what's happened and what they have, what would you be looking for there?
So commercial roofs are an interesting part of the tenant comfort, because they, on the sunny days, there's all that heat. And we say that the heat rises, but eventually it is going to get to the HVAC system air, and it's going to change the temperature coming out of the vents because it's going to be warmer. So instead of having air conditioning and you're getting a nice 60-degree temperature out of your vents, keeping the space at a 72, 74, when it picks up that heat in that ductwork in that space that's picking up the heat from the roof, you're going to start getting temperatures out closer to that 70, maybe 75. That system may run all day long and produce the exact same temperature as you want in the space, which means the space will never get there. Right. So when you do so that is a huge area where you can, especially when there's ductwork up there, where you can improve your HVAC system use by improving the building materials. So when you do that, when you do the fix there, then the ductwork, we may need to redesign the ductwork to put air into more spaces. We may need to put smaller and more supplies out there so that because eventually we're going to produce that 55, 60-degree air. It's not going to pick up the extra heat. So it's going to dump nice cold air, or on the other side, nice warm air in the space, but it's going to be 20 feet apart to each register. So it's not going to run for very long. So it's going to feel really great when you're sitting under that register. But when you're in the next cubicle or the next space over, you're not going to get enough air movement with the reduced operation of the HVAC to take advantage of the comfort and energy savings in space. So you'll need basically a redesign on the air distribution.
Great. Yep. Thank you very much for that.
Sure.
That's exactly what I was thinking. I don't see any more questions coming through right now. If there's anybody here that has a question, you can pop it in the chat. Otherwise, I think we are done for today. We have finished the webinar. If I have more questions that come through, I will definitely get those questions out to our presenters, and we'll get those questions answered. And then in my follow-up email, you guys will get all the answers and a recording of this video. So, all right. And I've had many requests for a recording of this video because a lot of people couldn't be here today, but they do want this information. So thank you very much to Sarah Jane and Robert and Kevin for doing your presentations with us today. Thank you.
Thanks, Diana.
All righty. You guys
Okay.
have a good day, and this is the end of our webinar. Bye,
Stay
Robert.
warm.
Bye, Kevin. Yeah, right. Bye, guys.
Bye-bye.